to Pythagorean Theorem, which is again involving triangles. So we're still on the geometry unit. And I like to start this lesson with a story. You want to hear it?
Yes.
It's a story about Pythagoras. Pythagoras was a mathematician. I need to look up his birth date. It's somewhere around 300 or 400 AD. Are you with me? It's a long time ago, like 1800 years ago. He was a very smart guy, and back then, mathematicians got math problems from real world problems, like building a building out of stone. Are you with me? And you'll see, we'll kind of tie that in. But Pythagoras, when he was a kid, back in that day, if you were rich, you got to have a tutor. So your parents would pay a tutor to teach you how to read or do math or whatever. So Pythagoras was, I guess, rich because he had a tutor. And he was a very smart young man. Every time his tutor would give him a math problem, it usually took him like a minute or two and he was done. And he'd be like, all right, what else, you know? So the tutor said, I'm going to fix young Pythagoras. Are you with me? So one day the tutor walked in and goes, Pythagoras, add up the numbers 1 to 1,000. Well, let me add a few more here. So the tutor is thinking, okay, this little kid is going to take him forever to add up 1 to 1,000. Because you got to do, you know, what's 1 plus 2?
3.
What's 3 plus 3?
6.
What's 6 plus 4?
10.
What's 10 plus 5?
15.
The tutor is thinking, okay, it's going to take young Pythagoras forever, right? So Pythagoras sits down, starts thinking about it, comes up with the answer in like 5 minutes. And the tutor's like, what? How did you get that? And Pythagoras was like, it's easy. What is 999 plus 1? What's 998 plus 2? What's 997 plus 3? What's 996 plus 4? What's 995 plus 5? Pythagoras is like, oh, that's easy. How many pairs of 1,000 are there?
Oh, wait, no. 10.
You say 500? So when we get to the middle, we will have, what, 499, 500, and 501, bless you. So when you get to the middle of adding all the numbers together, bless you. Okay, won't 501 and 499 add up to 1,000?
Yes.
And then isn't there an extra 1,000? And then isn't there one number that's not going to have a pair?
Yeah.
Are you with it? So, what is the answer here? How many pairs of 1,000 do we have?
6,500.
We actually have 500 pairs of 1,000. What's 500 times 1,000?
500,000.
500,000, thank you. And then, what number is the only number in the series that doesn't have a pair? 500, the one in the middle. So what is my total answer here?
500,000.
Good. Can you imagine how ticked off the tutor was? But Pythagoras actually figured up a way to count large numbers. This works for almost every sequence that you can try to add together. We actually have another theorem later that we developed from this problem. Are you with me? But talk about a smart kid. He's like, well, that ain't that hard. 991 plus 1, that's 1,000. There's another 1,000, 1,000, 1,000. So we actually have 499 pairs of 1,000, but then we have that number 1,000 out here. Are you with me? That makes 500 pairs. And then the one number in the middle doesn't have a pair, so we need to add it at the end. Pretty smart little kid, eh? Eh?
Yes, sir.
Y'all are not Canadian, eh? Eh? Okay. So let's get into his theorem that he discovered about right triangles. It's called the Pythagorean theorem. Here it is. A squared plus b squared always equals c squared. Now put a big star in your notes because this only works for right triangles. How do we know a triangle is a right triangle? Give me a clue. Bella. Yeah, it's got to have a 90-degree corner somewhere in it. If it does not have a 90-degree corner, we cannot use Pythagorean's theorem. Are you with it? All right, so let's talk about A, B, and C. C is the most important number out of this equation. C is always the longest side. And we have a big fancy name for it. You want to hear it? Actually, we'll just go for it. It is called the hypotenuse. Don't ask me where that came from. I do not know. It's a weird word. All right, y'all want to hear a joke?
Yeah.
What do you call it when you're on an airplane? Just set them down. We'll give them to her in a minute. Okay, what do you call it when you're on an airplane? You really got to go to the restroom. You go to the back of the restroom, and it says occupied, red. You're like, crap. What do we call that? Huh? No. Come on, people. We call it hypotenuse. A couple of you got it. Hypotenuse. Isn't the toilet also called a pot?
Yeah.
If you're in an airplane, aren't you very high?
Yeah.
Isn't somebody using the pot?
Yeah.
Because you want to use the pot? Okay. Math joke. They're not very good. Ethan's like, yeah, whatever. I thought it was kind of funny. Layla looked at me like, that's like a dad joke, Coach Murphree. Okay. Yeah. All right. So the side, that's the longest side. So let's look at this picture. I'll give you choices. 1, 2, or 3. Which side has to be the hypotenuse? 1, 2, or 3?
3.
3. So, do you see the 90-degree corner?
Yes.
Do you see the corner pointing to this side? Yeah. The 90 always points to side C, or the hypotenuse. You cannot mislabel that side. If you do not call this side C, you will miss every problem you do. Now, the other two sides, A and B, are what we call the legs. You can call any of the two sides whatever you want. You can call that one A and this one B, or you can call this one A and that one B. You can mix them up. That doesn't matter. A and B really don't matter. C is the only one that matters. Are you with it? All right, so I'm going to call this side A and this side B. So according to Pythagorean's theorem, when we take whatever number this side is, and we square it, and we add it to the little side and square it, it will always equal the big side squared every time. So let's do a few problems and see what we can do. Let's say that A is 3 and B is 4, and we want to find C. Let's plug in 3, let's plug in 4 into the equation, do a little math, and see what length side C should be. So what do you want to call A? What?
3 squared.
3 squared. What do you want to call B?
4 squared.
So let's do a little math. What's 3 squared?
9.
What's 4 squared?
16.
So we need to add 9 and 16 together. What's 9 plus 16? 25. Okay, so let's look at our answer. Our answer says some number squared makes 25. Do you know a number times itself that makes 25? Gabby? 5. Do y'all agree with Gabby that 5 times 5 is 25? So, the answer to this is 25, or excuse me, 5. Now, right here, let's say you didn't know the answer to what number times itself is 5. How do we undo c squared? What's the opposite of squaring? No, dividing is the opposite of multiplying. Square rooting is the opposite of squaring. So when you get it down to this part, you take the square root of this side and you take the square root of that side. What's the square root of c squared? C. The square root is going to cancel the square. And all you're left with is c. And then what's the square root of 25?
5.
Questions? We're going to do some more. So, Pythagorean's theorem, anytime we have a right triangle, will always work. Every time. Let's try some more. Let's make the numbers a little bigger. Let's go 12 and 16. Ooh. And we want to find C. All right, what do you want to call A? Aaliyah, your name starts with A. Which number do you want to call A?
16.
All right, 16 will work. Then what has to be B? Do we have any B's in here? Bella, that'll work. What do you want to call B?
12.
Has to be 12. Why could Bella not plug it in for C? Layla?
Because C is the biggest thing.
C is always the longest side and the 90 is pointing to C. This side is C. So C does not need a number on it. That's what we're going to find. All right, calculator time. What's 16 squared? 256. 256, thank you. 12 squared?
144.
And we need to add them together. What's 144 plus 256?
400.
What?
400.
Even?
Yes.
Nice. All right, and is 400 my answer?
No.
No, what do we need to do? Square root, both sides. What is the square root of 400?
20.
20, according to the calculator. So side C would be 20. Are you with me? All right. So when they give you A and B, you square them and you add them together. Let's do one where they give us C. Because they don't always just give you A and B. Sometimes they give you C. All right, let's put some numbers in here. Let's go with big numbers. They want me to find this side over here. All right, Keandra, what number are we going to plug in here, or where is 55 going to go in this equation? A, B, or C? A? Do y'all agree with A?
No.
Does anybody disagree with A? Why, Gabby?
Because the right corner always points to C.
So what side is this, Keandra? What side are we?
The one.
Yeah, so where does 55 have to go?
C.
Yep, you can't put it for A. You gotta put it for C. C is the most important thing you need to know. All right, sweet. Where do you want to put 33? Marcella?
B.
You want to put it for B? That'll work. So this time we're going to find out what number A is. Are you with it? Let's go. Calculator time. What's 33 squared?
1089.
1089. What is 55 squared?
3225.
3,200.
No, 2025.
Say it again. 2225?
No,
3025.
Thank you. When y'all are calling out numbers, just call them out. 3025. Don't try to put 3025. Just go 3025. Okay. All right, I got a question. If we're solving this equation, what are we going to do next? Ethan.
subtract 3025 minus 1000.
Good. Isn't this kind of like a two-step equation? To get A by itself, we need to get rid of this. What's the opposite of plus 1089?
Subtract.
Minus 1089. So now we've got A squared equals, okay, math time, calculator, what's 3025 minus 1089?
1936.
1936?
Yes.
Okay. And are we done? Is that the length? No, there's no way this side's gonna be 1936. That's too big, y'all agree? What do we do?
Divide by 8.
No, we do not divide.
Square root.
Square rooted. Thank you. I like that enthusiasm. Square rooted. Yeah. Nice. I like that. That was good, Ellen.
Wait, how do you do the square root?
Oh, good question. So on the left side of your calculator, right above the x squared button, find the x2 button. Look right above it in blue. You see the little square root symbol? So you got to hit blue x2 to get the square root to come up. So what is, that's a great question. What is the square root of 1936, Lily?
44.
44? Are you sure? Good. All right, questions. So this side would have to be 44. Any questions? Let's do one more. Because not all of them turn out to be whole numbers. You can get decimals. It is okay. No big deal. I'm going to change up the triangle. My 90 is down here now. What are y'all doing, boys? Let's go. 61 and 22. Let's solve this problem and find out the missing side. All right, Alina, what number up here has to be C? C is the most important thing. Do not mislabel C. 22 is C? So do you see my 90?
Oh, 61.
Oh, she caught it after that. Isn't the 90 pointing up here? Hello?
Yes.
So did y'all like her face?
Yes.
Very nice catch, Alina. Good. Because if you'd have put 22, she would have got the problem wrong. Now you're not going to get it wrong. All right. Skylar, where does 22 go?
B.
Anywhere you want. You want it to be B? That'll work. And let's find A again. All right, what's 22 squared, Aaron? 22 times 22.
284.
184? 484, thank you. What's 61 squared? Let's go with Madison. What, you sure? Oh, 3721, got it, that'll work. All right, what do I do to solve this problem from here, Jos? We need to get A squared by itself.
You subtract
Atta girl, that's what I wanted to hear. You gotta subtract what?
484.
Very nice.
And that cancels out. And yeah.
So what is 3721 minus 484?
3237.
3237? And is that my answer?
No.
So what do we do?
Square.
Oh, I wanted the song again. What do we do?
Square root.
Square root it. Okay. And we do get a decimal on this one, I believe.
56.89.
Okay, so whatever the decimal is, it can have 17 million numbers after the decimal. It's 57.84? 94?
56.89.
It's 56.89. Do not round. Put 56.8. I hate rounding. If the decimal keeps going, 9, 7, 2, 3, 8, whatever, we are going to do what's called truncating. Truncating means you don't round. You stop after the first number. 56.8. Done. No number, one number after the decimal. Do not round. I hate rounding. Are you with me? Questions? And that is how you do Pythagorean theorem. It's not bad.